quickly, we look into domain and range of exponential function. Yes. Let's solve these questions below. Find the domain and range of the following function. Question 1 says f of x is equal to a exponential x, where a is bigger than 0 and a is not equal to 0. Okay. Can we? Yes, we can. Let's try it out. F of x is equal to a power x. So we are considering when the base is a positive number, that is numbers bigger than 0. So a is not 0. Alright, so let's see what happens. Domain of this function, remember, is the values of x that will go here and give us an answer. Yeah. Let me throw more light on this function. You know, a function like this, an exponential function, there's something about 1. What happens? If a is bigger than 1, the function will be increasing rapidly, very fast. The function will what? Increase rapidly. What if a is less than 1? A is less than 1 and bigger than 0. Like I am saying that a is in between 0 and 1. What will happen? The function will decrease. Yes, the function will decrease. Yeah. Take notes. Now, even if the function decreases, let's say I have 0.25 to the power of, let's say, 20. Normally, this 0.25 is a number in between 0 and 1. This value is going to be small because 0.25 is in between 0 and 1. It's a proper fraction. But what if I have here 25 to the power of 20? Because 25 is bigger than 1. If anything here is bigger than 1, the function will increase rapidly. Yes. But my point is this: no matter how the function decreases, the function can never be equal to 0. The answer from this place can never be 0, no matter how rapid the function decreases. I am giving you and I am painting the image of the function for you. So I am saying that the output from exponential function must always be what? Positive. But it will not start from 0, because it can never be 0. It starts from the number after 0. That number is not 1. There are billions of numbers after 0. 0.0000001. Billions of numbers between 0 and 1. So quickly, let's just write the domain and range for our exponential function. So by domain, dom f, domain of this function is that we are looking for the values of x that will work. And I think, in fact, everything will work. Yes. Anything, any number that goes in here must give us an answer. Yeah. Therefore, my domain is all real numbers. Yes. Now the range. I've already explained the range for you to conserve time. So we can now see that the range of this function, meaning the possible output, possible answers, we can't have an answer here that is negative. Therefore, our answer will start from 0. But because the answer cannot be 0, because we can't have 0 from our exponential function, we are going to, is it close? No. We are going to open 0 to indicate that 0 cannot be the answer. So from 0 down to infinity. Any question? Comment section. Please like and subscribe for more videos like this. So our domain is this and our range is that. We have solved for question 1. Question 2, let's solve. 2 says g of x is equal to exponential x plus 1 plus 10. Alright, let's do this. G of x is equal to exponential x plus 1 plus 10. You know, E is a constant. E is a constant. The Euler's constant is about 2.718 thereabouts. So E is defined to be greater than 1. So this function will increase rapidly for the values of x. Yeah, x can be anything x feel like being, but the range is that domain means what can we put as x here? Domain, dom f. What can we put as x to have an answer? Everything will work. Yes, everything will work. It's just a simple polynomial function. Everything here will work. So my domain is all real numbers. The range is the interesting part. The range R sub f. You know, the range from this part of the question, from this part, we said that because it's exponential, we can't have 0. Yes, but we'll be getting bigger numbers down to infinity, to be increasing, provided our base is bigger than 1. Therefore, we are going to start from 0. Yeah, but we don't include 0. What does this mean? It means that we are including 0. So quickly, I will clean this. I will use open brackets to indicate that 0 is not inclusive. Check our video on interval notation down to infinity. Here is my range for this function. No! I have an extension. This is the range, assuming there was no shift here. There was no extension. But because I have plus 10, this range here starts from 0. But this one now, I will consider the extension. The range will now start from 10. When you have an extension, the range will start from that extension down to infinity. So my actual range is going to be 10. 10. Can it be 10? No. Down to infinity. It can't be 0. So 0 plus 10, which is 10, it can still be 10. Yeah. I know this part is confusing, but I think this is for those who are inclined in math or who want to dive into a mathematical course or engineering without doing all these things. So that will be all for now. If you learned something, please like and subscribe. Thank you for watching.